So I've been looking at the Apple Vision Pro, which is recently released. So if people aren't familiar with it, it's VR AR headset. Um, so before I show the video demo, it can do a couple of things. Like it can show you windows, obviously in space. It can show you volumes, which are basically anything up to a 2 meter cube. So if your object is bigger than that, you need to scale it down or it'll clip. And it can go into full immersion where it basically hides all the other applications and shows whatever models you're placing into your space at whatever scale you determine. Um, it uses their internal API for all this is called Reality Kit. And it's interesting because what it's doing in what they call Vision OS for the headset is different from what it does in the other OSs, even though it's the branded as the same API. So there's no camera, as far as I can tell, no lighting, like no directional light, no point light. There's image-based lighting instead. But if you're on Mac OS or iOS, you're on your iPad, it looks a lot more like 3JS, and there are the cameras and spotlights and point lights and all that kind of stuff. So if you're implementing and you wanted to implement sort of across all the platforms, you'd have to actually have two separate uh, implementations as far as the lighting and so forth goes. The other thing that is a bit of a interesting showstopper as far as using the assets we have is it's really focused. All the APIs use USDZ format, and I looked around for like a open source, GLB, GLTF loader, and all of them seem like they're kind of hobby projects and don't support everything, et cetera, et cetera. So the platform is really built around USDZ. So that led me to one, I had to convert assets over and host them in my own space. It would be nice if we had them centrally hosted. Second, thinking about what a choice looks like a multi-format annotation, so that you could make that have the software client load the file it desires. That might be good to have an example of that somewhere in our documentation early on, so that people who might be looking at it from the Apple point of view would know what to do. And so I have some examples, and I'll share that. But basically, it has not been hard to write a manifest loader, and let me just get that shared and show the video. So basically, our friendly astronaut, and thanks to Apple, they have this immersive moonscape background. So I loaded our astronauts up on the moon, and but you can see here's the model with the second astronaut double the size and loaded. But if you load them in reality, they're actually quite large. I know you talked about expanding them. This is in our digital humanities lab at Yale, and they're towering up over me and floating up in space. So that's but works fine. The models load fine. Positioning is fine. There's really nothing hard about what we're asking it to do. Especially with these simple models. I also loaded up. I'll jump ahead. I loaded up the cell. This is scaled to 2 meters on the long edge, which is actually the Z axis. It's like longer than it is wide or high. So it's not quite 2 meters high. But again, no problem loading it up, sticking my head into it, looking around, and so forth. So that worked fine. And I'll jump ahead to, I also tried a full scale, which is actually bigger than my office once I load this up. But again, no problem rendering it, no problem working with it. And again, using the image-based lighting, which I don't really know much about, it's kind of overlit or overly bright. It's also interesting, you can see out the little holes in the side to reality there. So again, no problem loading that. And then I think my favorite model, which we don't have in our set, but is from the Apollo 11 command module from the Smithsonian. And again, back to our space theme. This is a pretty detailed model. If you look in the switches and things on those control panels are individually modeled. They're not just in the texture. but again, no problem on the device loading it up, no problem uh, scaling, et cetera, doing the things I needed to do with it. Um, so not a lot to report other than it kind of all works as advertised. It is a little different because your headset is the camera. It's using image-based lighting, um, but seems to work pretty well. And as far as the just mechanics of loading the manifests and rendering, oh, this is full size in our digital humanities lab. No problem there. So just another interesting thing. I'd like to move on to annotation support and seeing what that will look like, but this just could be another